Hello. As you remember, up to now we have looked at why we need statistics and how we collect data and how we create frequency distributions, a summary of our dataset, and how we can draw a graphical form. And now we are going to look at a little bit mathematical side of the statistics. Okay, from now on, we will have lots of calculations. And one of the first things you need to understand with the data is where is the center of data. So in statistics we call it central tendency measures. So most of the time the data tries to cluster around some value. So we have random variables and we have the result of the random variable. So as you can hear from internet or other sources, the average age of buying specific product is 27 years old. So how did they calculate it and what kind of an average is it? So what we try to do is we use one number, which is the center of data, to represent the remaining part of the data set. So if you are interested in the average age of Anadolu Üniversitesi Open Education students, we look at the age of every student and we calculate the average value. So I'm trying to use the average value at the moment because the average value is the bigger picture of the averages. So what we try to do here is we will show you some different averages. So whatever is suitable for you, you will use in the future. So the central tendency measures will show you where might your data center is. So in statistics, we have mode, median, and arithmetic. So this is the most frequently used averages, and they are suitable for different purposes. Okay, so mode is the most frequent value, the most repeated observation value in your data set, and there's a restriction for the level of measurement. Only nominal, ordinal, and interval and ratio levels you can use mode value, but in arithmetic mean interval and ratio level can be used. So if you have nominal and ordinal level of data, you shouldn't use arithmetic mean, and probably that you are not going to be able to use it. And if you want to calculate the median, median is the middle value, the value of the middle value of the observations if those are ordered from smallest to highest or highest to smallest. So what we try to do in the median, we order our data from smallest to highest and find the middle one. Okay, so then it was going to be our average value. So there are some advantages and disadvantages in your book. You can read details about it. And let's start with mode. It's very easy to find mode. The mode is the most frequent value in your dataset. So if you create a frequency distribution, you just look at the frequencies and identify the highest frequency. If the highest frequency is 7, you have to look at the corresponding x value, and if the x value is 5, then you will say the mode is 5. And so here is a simple data set, and we have some observations here, and what you can do is, this is a raw data as it's collected from wherever it's collected, and as you can see, 1 2 3 4 observations is equal to 3. None other observations have a frequency equal to 4, so the number 3 is the most frequent observation in our data set. So the mode of this data is equal to 3. Sometimes in your exams, what you do is you try to find the most frequent observation, which is 3, and it is repeated 4 times, and you think that the mode value is 4. No, the mode value is 3, and the frequency of how many times it is repeated is equal to 4. So be careful. Once you find the most frequent number or the highest frequency, don't think it as a mode number. The mode number is whatever associated value with this frequency. And it says creating a frequency distribution of the data is always helpful. And remember from last week, our bar charts in bar charts, it's easy to see the frequencies of each column, so you can easily identify the most frequent value and you will find mod value easily. The second one is the median. It's widely used again, and when there's an outlier in our data, as you remember, we talked about an outlier, possible outlier for the male grades last week, and it's more suitable because the next average we will study arithmetic mean, and it's heavily affected by outliers but not the median. So what we do is median, we order our data, whatever your preference, it doesn't matter, smallest to largest or largest to smallest, and we find the middle value. So 50% of the observations will be less than median and 50% of the observations will be more than median. So when you have group frequency distributions, it's not that easy. So you cannot just easily find where the middle of your data is. We need to use this formula. So when you are studying your exam, please look at your book in this area and try to understand how we are going to use this formula. And what we try to do here is we use n/2 formula. So if there are 100 observations, it's going to be 50. So you have to find the 50th observation, and where is it going to be in your group frequency distribution. So there are classes, and in one of the classes you will have the 50th observation when the data is from ordered from smallest to largest. Once you create a group frequency distribution, your data set is already sorted. So we will use this formula to find what the median value is in group frequency distribution. So there are examples in your book, so I suggest you to study those examples. This third one, which is the most widely used one, probably whenever you hear word average, people are talking about the arithmetic means, and you start learning arithmetic mean in primary school. And in statistics, we have one uses of arithmetic mean, but we use two symbols, and these symbols are mu. When you see mu, it means that you are talking about population arithmetic mean. But also we have another symbol, here it is, we pronounce it as x bar. So x bar is for arithmetic mean, but what kind of an arithmetic mean? It's sample arithmetic mean. So rather than working with population arithmetic mean, if you take a small random data points and calculate the arithmetic mean, we will use x bar, and the formula is almost the same. The arithmetic mean is just sum up all the observation values and divide it by number of objects. So here we have I equal from 1 up to capital N. The capital N shows the number of objects in the population, and we add them up and divide them by the number of objects in the population. So we will have the population arithmetic mean, mu. In x bar, the structure of the formula is same, but this time I goes up from 1 to lowercase n. The lowercase n is the sample size, so divided by the number of objects. So you have 4, 5, 6 as your observations. So there are 3 observations. Let's say it's the population with 3 observations. So 6 plus 4, 10 plus 5, 15. 15 divided by 3, you will get the population arithmetic mean as equal to 5. And very simple thing to do. It's not too difficult to calculate. And remember, in chapter 3 we created chapter 3 and chapter 2 we saw frequency distribution. So we have categories. For each category we have a frequency. So if you want to calculate arithmetic mean for the frequency distribution, for each row we need to make a multiplication. So each observation value is repeated sometimes. We call it frequency. So let's say you have a frequency distribution. The first line of the observation is 1. The frequency is 7. So 7 times 1 is going to be, and the second one we will continue like this. So we have to find these multiplications values for each category. okay, then divided by the number of objects in your population. So it's the same for the formula for the sample arithmetic mean, but as you can see, we distinguish sample arithmetic mean and population arithmetic mean by the simple symbol we are using. The last one is going to be arithmetic mean for the group frequency distribution. And if you remember, in group frequency distribution, we have small classes like 0 to 10, 10 to 20, 20 to 30. So in the previous formula, we had one x value and one frequency value. But in group frequency distributions, we have an interval and associated a frequency. So what we do here is we pick up the middles of each category, like 0 to 10, the middle is 5, 10 to 20, middle is 15, and transform them as like our x values in this frequency distribution formula, and we call it middle values. So you have in group frequency distribution, you have classes, frequencies, and next to frequencies we will create a new column, and in this new column we will have the middles of each category. Then the formula is again very simple. Frequencies multiplied with the middle values and divided by number of objects, and we will get the arithmetic mean of the group frequency distribution. Since we are taking the middles of each class, the arithmetic mean in group frequency distributions will be a approximate value. Is never going to give you the exact value. So if you have the data set itself without creating a group frequency distribution, it's better to calculate the arithmetic mean using with the raw data set. But time to time you will get the data from other sources, and if this other source gives you the data in a form of group frequency distribution, maybe you have to calculate arithmetic mean using this group frequency distribution. Then this formula will be used, but you have to always remember that when you are working with group frequency distributions, the arithmetic mean you will produce will be an approximate value, unless you use exact numbers from the real data set. Another approach in arithmetic mean is to look at weights. So it's very easy to see an example from a student's life. Assessment on a course. As you can see, there are different assessment methods. We have midterm exam, coursework, unannounced quizzes, and final exam. And their weights or the preference of the importance is different. So the final exam gets 50% of importance, whereas the quizzes gets only 10% of importance. So if you get 100 in one quiz, it will only affect your overall score by 10%. But if you get a final exam as 100, it will get your overall score with 50% of importance. So we have to reflect this changing of importances, and we will call it weighted arithmetic mean, and the weights will come as multipliers to our x values. So the formula very looks like the arithmetic mean formula for a frequency distribution. Only one thing is changed. Now, rather than we have frequencies here, we have the weights. But for frequency distribution, for each category, if you can create a weight, then again you can use this formula for a weighted arithmetic mean, and you will just add up an fi here, and you will calculate the result you are looking for. So the weighted arithmetic mean is useful when you can have assign different importances for different parts of your overall value. There is another average we may be using, and when you have percentages, ratios, indexes, the geometric mean is a better approach. You can't just take arithmetic mean of index numbers to talk about the average. So the better approach is to use geometric mean. In order to calculate the geometric mean, we have to multiply the observations. Okay, so if there are 4 observations, each observation value will be multiplied with each other, and we will take a square root to the power of the number of objects. So if there are 5 observations, we will take a square root to the 5. And then we will find a geometric mean. And remember when we were talking about dot plots, there was an outlier situation, possible outlier situation for males. So arithmetic mean is heavily affected by these outliers. So there are some robust methods in statistics. Okay, so we have trimmed mean and winsorized mean, and some of these are used in sports scorings. And in trimmed mean, we throw away some portion of the data. So what we do is we calculate, let's say, 10% of the data, and we remove the number of objects from minimum and maximum of our data by whatever this trimming value is. So the trimming value is between 0 and 1%, so maybe 20% or maybe 40%. So we throw away some data points in trimmed mean from bottom and upside of the data, and we will try to calculate arithmetic mean which is remained after this trimming. In winsorized mean, we have the same approach, but rather than throwing away our observations, the observations on the left hand side or the minimum and maximum side of the data is replaced by the numbers next to them respectively, and find our new data set as in arithmetic mean. Okay, so this week we just looked at averages, and we looked at the averages as the center of data. Mode, median, and arithmetic mean is most widely used. Geometric mean can be used for indexes and percentages. If you want to attach importance to categories, you can look at weighted arithmetic mean. And if you think that you have a problem with outliers in your data affecting your average values, then you may go to a more robust estimators and might use trimmed and winsorized mean. See you in next week's chapter.